Ever wondered why data structures and algorithms are so important in tech interviews? Hi, I'm Vijay and welcome to VL Coding channel where we break down complex coding concepts into simple steps. Today we'll start the basics of DSA, what it is, where it is used and why every developer must master it. Next thing is data structure and algorithm is a fundamental part of computer science that teaches you how to think and solve complex problems systematically. Using the right data structure and algorithm makes your program run faster, especially when working with lots of data. Next thing is knowing DSA can help you to perform better in job interviews and land great jobs in tech companies. This tutorial is made to help you learn data structures and algorithms fast and easy. The next thing is first you will learn the fundamentals of DSA. Understanding different data structures, basic algorithm concepts and how they are used in programming. Then you will learn about complex data structures like trees and graphs, study advanced sorting and searching algorithms. Explore concepts like time complexity and more. This tutorial will give you a solid foundation in data structures and algorithm, an essential skill for any software developer. Next thing is, although data structures and algorithm is actually not specific to any programming language, you should have a basic understanding of programming in one of these common programming languages like Python, C, C++, Java and JavaScript. And the next thing is data structure is about how data can be stored in different structures. Algorithms is about to solve different problems, often by searching through and manipulating data structures. And the next thing is a data structure is a way to store data. We structure data in different ways depending on what data we have and what we want to do with it. For example, family tree. Let's consider an example without computers in mind, just it to get the idea. If you want to store data about people we are related to, we use a family tree as the data structure. We choose a family tree as the data structure because we have information about peoples we are related to and how they are related, and we want an overview so that we can easily find a specific family member several generations back. With such a tree data structure visually in front of you, it is easy to see. For example, what is the relationship between the family members? Like that. But without the links from child to parents that this data structure provides, it would be difficult to determine how individuals are related. Data structures give us the possibility to manage large amount of data efficiently for uses such as large databases and internet indexing services. Data structures are essential ingredients in creating fast and powerful algorithm. They help in managing and organizing data, reduce complexity and increase efficiency. And next thing is, in computer science there are two different kinds of data structures. One is primitive data structure and another one is abstract data structure. What is primitive data structure? Primitive data structures are basic data structures provided by programming language to represent single values such as integers, floating points, characters and booleans. And abstract data structures are high level data structures that are built in using primitive data types and provide complex and specialized operations. Some common example of abstract data structures include linked list, stacks, queues, trees and graphs. And next thing is an algorithm is a set of step-by-step instruction to solve a given problem or achieve a specific goal. Let's take an example of any recipe. A cooking recipe written on a paper is an example of an algorithm where the goal is to make a certain dinner. The steps needed to make a specific dinner are described exactly. When we talk about algorithm in computer science, the step-by-step instructions are written in a programming language. Instead of food ingredients, an algorithm uses data structures. For example, examples of an algorithms are finding the fastest route in GPS navigation system, navigating an airplane and a car, finding what users such as, for example, search engines, sorting for example, sorting movies like rating. The algorithms we will look at in these tutorials are designed to solve specific problems and are often made to work on specific data structures. For example, the bubble sort algorithm is designed to sort values and is made to work on arrays. Data structures and algorithms go hand in hand. A data structure is not worth much if you can't search through it or manipulate it efficiently using algorithms. And the algorithm in this tutorial are not worth much with a data structure to work on. DSA is finding efficient way to store and retrieve data to perform operations on data and to solve specific problems. By understanding, you can decide which data structures or algorithm is best for a given solution, make programs that run faster or use less memory, understanding how to approach complex problems and solve them in a systematic way. And next thing is, data structures and algorithms are used in virtually every software systems, from operating systems to web applications, for managing large amount of data, for task scheduling, for planning routes, for optimizing processes, for solving complex problems. DSA is fundamental in nearly every part of the software world. For example, operating system, database systems, web applications, machine learning, video games, cryptographic systems, data analysis, search engine. So that's it for this video. Thanks for watching. On the next video, we will explore two different algorithms that generates the first 100 Fibonacci numbers using only primitive data structures. One will use a simple loop and other will dive into the power of recursion. Make sure you stick around it and don't miss it.